the Local 5 Weather Lab. Today we're going to talk about temperature inversions. Now, typically in the atmosphere, the temperature cools with height because the ideal gas law. It cools at an exponentially inverse rate, so we call it a logarithmic rate. It doesn't really cool a whole lot at first, but then as you get up towards we call the tropopause, the border between the lowest level of the atmosphere, the troposphere, and the stratosphere, then it starts to go back the other way. As the temperature actually warms in the stratosphere. Typically, it only cools in the lower levels of the atmosphere, but when you have a temperature inversion present, it does the opposite. See that quick little nose it did right there? So actually what the temperature did when you have an inversion is it kind of rises in the bottom 5,000 or 10,000 feet in the atmosphere just above the surface. And this doesn't really happen that often. It happens a lot in the spring and summer, not really a whole lot in the winter. But it can have some interesting impacts, especially as it has to do with severe weather and fog. Those are probably the two biggest impacts. So the biggest takeaway from this graphic is an inversion is when the air just above the ground starts to actually warm instead of cool, which is kind of the opposite of what the ideal gas law should say, how the atmosphere should essentially behave. So what does that actually do? What impacts do inversions have? Well, typically, any clouds or precipitation is limited because basically the air parcel has to penetrate through where the air is warming, and where that air is actually warming, that's what we call the air is stabilized. So there's not really any energy in the atmosphere. It's actually the opposite. So the air can't get above that certain level where that inversion is present. So everything is trapped below. Smoke, smog, fog. This is a really good case study back in 1952. The Great Smog of London occurred. Very interesting story from back then, about 70 years ago. And an inversion happened. It trapped a lot of the smoke and the pollution in London and the United Kingdom. And it created some big-time problems there. But what it also does in the summer is it acts as a cap. You might have heard of that term before, a cap in the atmosphere. It's kind of like a lid over preventing anything from really happening. It's blue skies, maybe some high clouds, some cumulus clouds out there. But you're waiting, maybe there's a severe thunderstorm risk that day. Once that cap, as in once the inversion is broken by an incoming cold front, you need some sort of forcing to get over that little warm nose we saw on that graph. That can actually lead to some explosive thunderstorm development. But I'd say that's mainly a Texas and Oklahoma, Southern Plains issue for them. What it really means really across the Midwest is a bit of a fog issue because it kind of traps the warm air just above the surface. It keeps cold air nearer to the surface, so it lessens the heating rate at the surface. And what that does is it allows fog to form quickly, and because the air is kind of trapped, let's say the inversion's at 3,000 feet, because no clouds can basically get above 3,000 feet, all those low clouds and fog are trapped below that level, causing some visibility concerns and also, like we said, severe weather concerns as well. Mainly that's a Southern Plains issue for the severe weather, but here across the Midwest, the upper Midwest, fog can be the main issue with temperature inversions. When we get into the spring, though, that could return for central Iowa in terms of the severe weather concerns. So if you kind of hear us talk about, oh, there's a cap in the atmosphere, that's what it is. It's a temperature inversion that can limit thunderstorm development at first, but then once it gets going, can really explode into some violent thunderstorms. Some really significant tornadoes have happened after the cap was broken across the plains. That's it for now from Local 5 Weather Lab. I'm meteorologist Dave Downey.